Hi, in this video I am going to go through an example where I am writing a function, storing it in a separate file. I usually just call my function file. So usually filled with several functions. And then using that function, doing a source function in order to load it. So let me start off by changing my working directory, which is a common first step. Now here, I can go down to my files pane. If I need help writing that line 2 of code, I can click navigating into the file that's storing that data that I want. If you don't know what you want yet, just go into an organized file. But then I'm going to click on this little gear and then select Set as Working Directory. And when I do that, it writes the code for me. It actually runs it as well. And so I can see that the code is already run because this changed from just // to tilde, which stands for my home directory, and then the name of the directory, or the path to the directory I'm currently in within my home directory. Okay, so I'm going to copy and paste that up here, which I've already done, which means that if I start RStudio over and it's starting back at / or tilde/, I can run this line of code and it sets my working directory immediately. I then have a source function, but this is not actually where I start to write the code. So I'm just going to just ignore this for now. I'm going to show you like, all right, if I am having this challenge of I want to write a code that transforms data into a binomial distribution. Well, the formula to do that is fairly simple. So take values, subtract minimum, and divide. Oh, okay, we'll just do this all in caps. And divide by the difference between the max and min. Okay, so that's the process, not terribly difficult. So if I want to test this out, I just need to determine like what should the inputs be. So start off by determining what are the inputs. Well, in this situation, the inputs are just x. I'll need an x in order to do some calculations on. I don't need like x mean, and I don't need x min and x max, because I can calculate that within the code. So in order to do this, I can just make some test data. I always recommend starting with making some test data, or at least I generally do. Oh, and let's just put a 50 in here. So that'll be pretty obvious. So in the end, these should be very low numbers. This one should end up at 0.5, and then this one should end up at 1 as the maximum value. Okay, so I need to then just work through this challenge, like what do I want this code to do? In this case, I want to subtract the minimum of x. It's going to need to be in parentheses because it's going to be lower priority to do that subtraction otherwise when compared to division. Then again, I'm going to put in parentheses the difference between the maximum and the minimum. So if this is x, then this becomes pretty understandable, 0 through 99. This is going to be 100 minus 1, which is going to give us a denominator of 99, which means 0 divided by 99 is 0, so that's at the bottom end of our binomial. And then 99 divided by 99 is 1. That's at the top of our binomial. If I do this, I can see the output. And so I've now saved it to a new object I've called y. I could keep working with this. I could say, like, let's have a z where I don't actually just want y as an output. I want, like, maybe I want a data frame, something that I can use later on. So let's start a data frame up. And I usually recommend giving data frames like some pretty, like, informative values. So I'm just going to call this orig, and this will be the original values. And then we'll call, there we go, bin binomial. We'll call that for y. So then just testing that, it's looking good. I can see my code right there. And I usually recommend using the return function to manually decide what data gets returned. In this case, it's not too bad, but sometimes it can be a little challenging to determine what actually is going to be returned, especially when you start mixing in like plots and other more complicated piece of code. So at this point is when you should probably start writing the actual function. Even then though, I will sometimes recommend, just in case, try clearing your environment, making your test data again, making Y, making Z, checking to make sure it's still working. Cool, it is still working. So I'm going to make this into a function now. This was only ever test data. The idea is that the function allows me to replicate a process from different starting positions. So we're going to call this, I don't know, Bino fun. Sounds good. Sounds exciting. And then I'm going to use the function to start my function. The code goes inside the curly brackets. And the only pieces I'm missing is what should my arguments be? Well, do I need X? Do I need to include the minimum of X? Do I need Y? Do I need Z? Well, the only thing I need to do this whole process is the original vector of values. So this should only have one argument. I then need to decide, should it have any default values? Well, no, I don't think it needs a default value because it wouldn't make sense to do this on anything that's default. Like this is a pretty customized transformation. Why would I want this to just produce a certain data frame every time I ran it? I don't. I want to produce a different data frame every time I give it different values. So at this point, I'm going to test it again. I'm going to run the function. I'm going to just try to see if I can make it work. I can envision a process where I want to just take some values like 1 through 150, run this, and produce a good data frame that works. I could also see where I just want to add some rnorm values. And because if I do this, it's just going to give me, we'll say, standard deviation of 10. When I do this, I'm still just going to get a nice little binomial distribution. So if I scroll through here, eventually I'll find the max and the minimum, and I'll see that their binomial value has been scaled to 0, somewhere in here. And there it is. They were right next to each other. How funny. So here's 0 and here's 1, which is purely coincidental. But yeah, so I mean, that's all working. So I've tested it. I feel good about it. So now I'm ready to put it into its own file. So again, just going to clear my environment, really being very conservative with that environment because I don't want it to get me confused. I'm going to take my function and I'm going to put it into its own file. Obviously, I already had one from a previous time. So I'm putting its own file. I'm going to save it into that same directory. And when I do this, I'm going to click Source on Save. Source on Save, marvelous tool. It actually has a lot of other capabilities, but its big one is going to be demonstrated when I save. So let me clear my console so you can see what it does. Note my environment is empty right now, and then when I click on this, it's going to source this file. That means it's going to run all the code in this file. That does include, like, if I just had some other stuff down at the bottom, whenever I run this, that appears. So I don't want that typically. I usually just want functions inside my function files. Keeps me organized. So this is what I want. I source it. It works. Cool. Now, what is it doing when it's sourcing it? It's actually using a function called source, given a path to that file. I could simplify that path since I set my working directory, but it does the full path by itself. And it loads all of the code inside of here, which happens to create BinoFun. So the idea at this point is, once you've kind of fixed your code, maybe you can copy over some explaining comments. But the idea is this function should just be that function. This function file should just be that function or a series of other functions. That's at least the general concept that I use. So at this point, I'm going to take that source function. I'm going to put it in here. I'd already done that, but that's where I'm actually loading the function. I can then write some test data just to show me using this. But first, I'm going to clear my environment to make sure this all works. I can even trim up this source file, this source function, so that it doesn't, it only ever works if I'm in the right directory, which is often something I want to happen. So set working directory, I can see that that worked. Source that file, I can see that that worked. Create some test data, cool, it worked. And then try running the function. Here I'm going to see that there was a mismatch between what I was doing. I could either go take this and edit my function, or I could have changed the code. But here, that actually makes sense. I'm returning a data frame from the binary function. So maybe I could have had a version that just returned the y value instead of z. And that maybe I'd be just called binafun, which is what I had before. So I'm going to, or binofun. So I am going to save this. When I do that, I can see a new function's appeared, and so I'm going to clear my environment yet again and test it all now that I think I've got it how I want it. I source it. There it is, binofun, some test data. I'm going to make that bina into bino for binomial, and then run it. And hey, it is working. And that's the idea. This process was isolated. I don't now have a z and an x and a y in my environment. That all occurred inside of this function file. The other, so that's the end of it. So just stop watching if you're good. The other nice thing about the function file concept is it allows me to use the debug mode, which means that I can come over here, I can click just out in this little gray space that puts a red dot, and when I save it now, I get a special version of source called debug source. And debug source is really cool because it means when I run this, and here's my current environment, it's going to change. I'm about to run it. When I do that, I can now see the environment inside of binofun, which is a really cool ability that you only really get if you're using this strategy of putting your function into a standalone file that you're sourcing. So at this point, I can now kind of see what my internal function sees. I can just make sure it's working. So cool, it's making x. This is what it thinks x is right now. That was my input. Here's y. This is what it had calculated here. So then it makes z, and then it returns z. So I'm double checking things, and yeah, it looks good. So I can stop, undo that, source it again. That little red dot goes away. And I'm feeling nice and confident moving on to the next coding challenge. And that's it. I hope that helped. Weird sound effect. Have a good day.